The melting point is the amount of energy required to break bonds and change solid phase of a substance to a liquid. Usually, the stronger the bonds between the atoms in an element are, the more the energy required to break them is. Thus, there is a direct relationship between the high melting points and strong atomic bonds. There are three factors that affect the melting point of periodic trends: metallic bonding, giant covalent structure, and ionic bonding.
Liquid equals the external pressure surrounding the liquid. Therefore, the boiling point of a liquid depends on atmospheric pressure. The boiling point becomes lower as the external pressure is reduced. There are three common metal elements, sodium, magnesium, and aluminum, that have metallic bonding, in which positive metal ions are attracted to delocalized electrons, going from sodium to aluminum. The charge on the metal ions increase from a positive 1 to a positive 3, with magnesium at positive 2. The number of delocalized electrons increase, so the strength of the metallic bonding increase and the melting points and boiling points increase. Silicon is a metalloid, an element with some of the properties of metals and some of the properties of nonmetals. Silicon has giant covalent bonding. Silicon has a very high melting point and boiling point because all the silicon atoms are held together by strong covalent bonds which need a very large amount of energy to be broken.
They are all nonmetals and they exist as small, separate molecules. Phosphorus, sulfur, and chlorine exist as simple molecules with strong covalent bonds between their atoms. Argon exists as separate atoms. It is monatomic. Their melting and boiling points are very low because when these four substances melt or boil, it is the van der Waals forces between the molecules which are broken, which are very weak bonds, so little energy is needed to overcome them.
Phosphorus exists as P4 molecules, sulfur exists as S8 molecules, chlorine exists as Cl2 molecules, argon exists individual Ar atoms. The strength of the van der Waals force decrease as the size of the molecule decrease, so the melting point and boiling points decrease in the order of S8 is greater than P4, greater than Cl2, greater than Ar.
So the trends that we can find is that the metals have a high melting point and a high boiling point generally, while nonmetals have a low boiling point and melting point generally. There is, however, one exception to this theory: carbon. Carbon has the highest melting point and boiling point out of all the elements, and it's a nonmetal. A good way to remember this is to picture a riot. Now, this may not be the most pleasant picture, but it's a pretty good way to understand this. To break up a big riot, you need a lot of police officers to help. Sort of like to melt an element with a lot of bonds, you need a lot of energy. But remember, there are exceptions, such as I mentioned earlier, like carbon. Thanks for listening.